Quack, quack. In the words of the penguin, quack, quack. Got it wrong. Hope you got that right. Thanks for taking our quiz with us. True or false? Another quiz question. A faster CPU is a better CPU. Well, the answer is obviously true. Is a faster CPU a cooler CPU? Aha. Lately, a number of technology advances have allowed processors to do a lot more work with fewer megahertz, less power. And Intel's newest is really a dynamo. You've seen probably a lot of talk about it, the Core 2. Well, we don't believe in talk here at Call for Help. We believe in hard numbers.
That's right.
That's why we put Sean Carruthers to work in the lab with the Core 2. This is the Conroe chip.
Right.
Came out in August, and everybody's just been raving about it.
Yeah, in a previous episode, I mistakenly called it the Crusoe, which was one of the original chips. It was designed to be low power and high performance. But this is the Conroe.
And the laptop's the Merom.
Merom.
Okay.
And so the Conroe and the Merom are both actually based on laptop technology.
You know, an interesting thing. Well, it's a Pentium M.
Right.
It's the Israeli guys, and it was really Plan B for Intel. And somebody told me, an expert in chips said, you know, it's really a lot more like a Pentium 3 than it is a Pentium 4. Yet, they've gotten so efficient, they've gotten so good at this, that they really get a lot more horsepower for fewer watts.
It's true. And when these ones came out, again, there's been a drive towards higher frequencies all the time.
Yeah, they were going to do a 4 gigahertz chip, and then Intel for some reason said no.
Right.
Too hot, I guess.
Right. And in that respect, Moore's law sort of went off the rails a little bit. But then they released the Pentium M. Like I said, it clocked back a lot and still performed quite the same.
So we've been telling people for now a couple of years, don't look at the megahertz or the gigahertz. That's not the most important measure of speed.
It's almost not important at all anymore. Obviously, within a chip, within a CPU line, higher megahertz will be faster.
So why does it not matter? Why can we have lower megahertz on a Conroe or a Core 2 and still get more performance? I don't understand.
Well,
how does that?
They've just made the insides of the processor more efficient.
It gets more done in less time.
It gets more done in less time. And we put this to the test. So, I mean, both the Core 2, which is the desktop version, and the Core 2 Duo, which is the notebook version, they're based roughly around the same thing, just slightly different innards, but they're roughly both notebook chips. They both use speed step technology, which is something that you saw in the notebooks before, which will actually clock your CPU down when it's not actually doing anything.
That saves you battery life.
That saves you battery life, saves you energy, and actually prevents heat from going inside the machine. So you can actually do more inside the machine that way as well. You don't have to cool it as much. More of the energy inside your computer can be dedicated to the
fans and all that stuff.
Right.
Yeah.
So we did our usual batch of benchmark tests to find out just how much. I was assuming, scaling it back like that in terms of the megahertz, that it actually wouldn't be as good as the previous Extreme Edition version, which was running 4 cores. It was hyper-threaded and dual-core.
That was a Pentium.
It was Pentium D Extreme Edition in 955. So that was running at 3.4 gigahertz. This one actually brought it down. I've tested 2 versions, one running at 2.66 and one running at 2.93.
Look at these numbers.
But yeah, so you can see right off the bat with
bigger
Sysmark,
is better, right?
Bigger is better. So we got 40 to 50% benefit on
over the Extreme Edition.
Over the Extreme Edition,
which was very expensive.
And that's even with the lesser version here. You're getting 40%. That's on Sysmark, the overall system benchmark. When you start going into other ones, PC Mark again,
it's not quite as dramatic.
Not quite as dramatic,
but still a big difference.
And
34%.
Sandra,
holy cow!
CPU arithmetic. This is where it really shines.
This is CPU bound, doing integer arithmetic
by itself. Right. So 66 to 77%. And again, 40 to 50%.
The light blue is the Core 2. The green is the Core 2 Extreme, which has more cache and is a little faster.
Right.
Okay.
And this is really where the benefit comes in here.
Now, this is a case where lower is better. This is how much power this is.
Power consumption. I used the kilowatt testing device to figure out how much wattage this thing was consuming, both in idle mode and in full benchmark
Now, that's important
mode.
for a laptop. Does it matter as much in a desktop?
Well, heat is an issue at that point. Desktop machines can be very noisy.
Because they have to have these big fans and stuff.
Right.
So these Core 2s are actually quieter, lower power, significantly lower power.
Yeah, so they're 60% of the power of the previous generation.
Less power.
And you couldn't even tell when it was spinning up, even in full mode, because the fan wasn't spinning up like it used to.
It's remarkable. Here's a chip that's 50 to 60% faster and uses a third of the power.
Right, and all I did was swap out the processor. Everything else was the same.
Very, very interesting. Well, it's certainly a strong recommendation for the Core 2, and that's what we're saying. If you're buying a new computer, absolutely. Core 2 for the desktop, Core 2 Duo for the laptop. They really do perform better and use less power. Sean Carruthers is our resident lab rat, co-host of the Lab Rats podcast, where they do a lot of this kind of thing.